Hello everyone, welcome back. So in this video we are going to understand the question we have based on the ones right that we have seen. So this is the third part of this problem, right, where we see type of question. Okay, so if you remember the ones problem, right, this is the ones two, right, this is ones two, and we have seen ones one, right. It's a similar kind of problem, little changes are there. Question saying that find the minimum area to cover all ones. And in the question, it is saying that you are given 2D binary grid. Know the binary grid, right? The value will be either 1 or 0. You need to find 3 non-overlapping rectangles, right? You have to find 3 non-overlapping rectangles having non-zero area with horizontal and vertical side, such that all ones in the grid lie inside these rectangles. Okay, what is saying? We have to find 3 non-overlapping rectangles with non-zero area. Okay, with horizontal and vertical sides, and all the ones in the grid lie inside these rectangles. I hope you understand, right? Return the minimum possible area, sum of the area, right, of these rectangles. Okay, and we can touch the rectangles. Okay, this is what we have given in the example. As you can see, it is saying the ones at 0 0 and 1 0 are covered by rectangle whose area is 2. Okay, 1s at 0 2 and 1 2 are covered by rectangle of area 2, and the 1 at 1 1 is covered by rectangle area 1. Okay, it means what? It means we have given this binary grid where you will see zeros and ones, right? And we need to cover all the area 1s, right? Exactly how? Exactly in 3 rectangles, right? In such a way, the rectangles, you can say the x-axis, right, you can say the side parallel, right, to the grid axis. Okay, so if we assume this is your the size grid axes, so we can say this one and this one we will consider. Okay, so this is the x-axis and this is y-axis. So the side parallel to the grid axis, we can say the rectangles are axis aligned, right? And when we say rectangles do not overlap, so but they can touch like this, we can say. If we talk about this and this, it is touching by this. If you can say 1 and 1, it will touch by this, right? Is it? That you have to understand. Okay, and other question is also saying we have to find what? The minimum sum of area where 3 rectangles we need from here. So in the very first case, 1s is at where? At this 0 0. Then we have at 1 0. You can say from here to here, we can say, right? When column is 0, so if you talk about the 0 0, means I am talking about this cell, right? And 1 0 means we are talking about this cell. Why? Why? Because we know that if this is 0 and this is 1, this is our row 0 and row 1. This is our column 0, column 1 and column 2, right? So this will become your 0 0 and this will become your 1 0, right? So very first it is talking about what? We have like this, right? 1 0 1 1 1 1, and it is talking about this very first one, where if you talk about the area, it is 2 into 1. height is 2, width is 1, so it will give you 2, right? Then it is saying 0 2, where we have this is your 0 and this is your 2, right? So we'll say 0 2, we are talking about this one, right? And another we have is 1 2, means this, there forms another rectangle, right? This one, it's also 2 into 1 equal to 2. Then it is saying there is only one we have at here, this one, third one. We have to find 3 rectangles. So here 1 into 1 equal to 1. Total, if we'll add, it will give you 5. That is why you are getting 5 here. Understand? So we have this binary grid we have given, where you will have 1 or zeros, 1s and 1s and 0s, right? And we need to cover all 1s using 3 rectangles, like rectangle 1, rectangle 2, and rectangle 3 we have found, right? And the rectangles are x-axis aligned, it is saying. Okay, you can say this is axis. Okay, align the sides parallel to the grid axis, right? We can say it should be aligned, and the rectangles do not have overlap. So if you say this one and this one are not overlapping, okay, it is touching. Okay, we can touch it. I hope you understand. This is the question was saying. What is our goal? Our goal is to find the minimum sum of areas of these rectangles. If you do the sum, means we are going to do plus plus. So you have to return this, you have to minimize the sum of the area and we have to return it. So you have to think like group of all 1s in 3 disjoint boxes that we have seen here, right? It should cover by all ones, right? And we have to make the boxes as tight as possible to minimize the waste area, right? In this case, it's good, right? We cannot say, let's suppose for this case, if you say, okay, I'll take one this one, this one, how many become 1 plus 1, right? Let's suppose you will say only I will take this one, I will take this one. 1 plus 1 area is 2, and I will take from here to here, right? 3 cross 1. So how many? 3 plus 2. It will give you still, it is giving 5, but in case maybe a possibility that it can become larger. But we have to do what? We have to make all the boxes, means the rectangles, as tight as possible, so that our the area, right, we will minimize the waste area, we can say. Okay, to minimize the waste area, we can say that. Okay. So let's talk about the intuition of this problem. So there are 3 rectangles, right? That means the grid can be split into, this grid can be split into what? In the few ways, we can say. Very first, it is saying 3 horizontal strips, right? So it means it should stack the top to the bottom, right? We can say that, right? Why I'm talking about this? Because see, we have given that there should be how many rectangles? 3 rectangles will be there, right? There are only 3 rectangles. What does it mean? That the grid can be splitted in how many ways? Only few structure ways, right? Where you can have 3 horizontal strips, means it will stack like this. If you talk, one will be here, one will be here, and one will be here. So as a stack, we can say how many rectangles we will put together. 3 strips, horizontal strip will be there, 1, 2, and 3, right? If you'll make, so we can say the horizontal strip we will make, right, as a stack from top to bottom. Can we say that? Similarly, there is another possibility that there will be vertical strips will be there, right? So in the case of 1, 2, and 3, right? So we'll say 3 vertical strips will be possible, right? So that from left to right, if we will go right, so we can in the stack we can say we can make the 3 vertical strips, right? Think about the third one. Can we say there will be some possibility, let's suppose for in this case if it is 0, right? So we can make, or the grid can be bigger, right? In the case it will become, let's suppose there will be in any form, either you will form like this and it will become like this, okay? So it forms like this, or if you write like this, let's suppose the possibility, these are the possibility, okay, in any direction. So this is look like as a kind of L, right? Either reverse, if you rotating it, right? So you can say there is another possibility, the L shape, or you can say you can write like this also, right? uh, okay, if you form anything it will become L size only, yeah, we can say. So the possibilities are there will be 3 horizontal steps, 3 vertical steps, and 1 L shape partitions, you can say. This time you say partitions. Why we are saying partitions? So one rectangle will be above, right, and 2 rectangle will be below, or one rectangle will be on the left, right, or let's suppose like this on the left, and 2 will be the rectangle in the right, right? So this is here and 2 will be there. If this is on the left and 2 will be on the right, okay, like this we can say that, okay. Or if you revert it, it will also become like this, right? So the same thing will happen. I hope you understand. So there are the 3 possibilities are there. And so when you write your code, right, you should try all these partitions by a brute force, right? So we can cover all the possibilities, right? So this is what as an idea we can say, when we'll write the code you should have, right? Now understand some functions that we are going to implement, right? Very first that we have given, so I'm talking about this function, or you can say method, where we very first we have grid, then we'll say u, t, l, and r, right? It means this function will calculate the smallest rectangle that cover all ones, okay, inside the subgrid from where, from u to l, right, to d to r, understand? So if it finds the mean I to max j, we can say, right, and max j to max I, max mean I, mean j to max j, right, means there will be a bounding box, right, we can say that. So let's suppose you are going from, I'm talking about u to d, right, because we have to go, right? Similarly we have to go for uh, j to you can say r, right, because we know that our subgrid is from where, u to l and d to r, okay. That is why we'll take the mean j, right, we'll have the mean I, mean max I, then will be the j will be there, right? Mean max you can say for both I and j. And uh, uh, so we can say these are the boundary boxes, we can say, right? If you understand mean I, mean j, right, we can understand, okay. That is the boundary box for ones. We have to return the area of the bounding box because we already have this, right? So if there are no ones in the region, it should return what? Infinity, right? Means infinite value should be returned, means invalid rectangle will be there, okay. So this is what we can say, we'll find the grid, right, and we'll calculate in the last, we'll multiply, right, and see here, right, the area of rectangles covering all ones we will get, right? So because we are building, we are checking each time, if it is equal to 1, we'll find mean I, mean j, max I, right, max j, we will get it. And once you will have, just need to multiply, right? And you will get the value. Okay, now understand how to rotate, right? So we know that if we'll rotate the grid by 90 degrees clockwise, so it is a really clever idea, you can say. Instead of writing the separate code for the vertical flips, you can say, when we do the splitting, vertical splitting, right? So that time, at that time, uh, we just rotate the grid, right? And we'll reuse the same horizontal logic, right? So let's suppose you are going for the solving the any grid, right? And when you solve the grid, for example this case, if you're going to solve the grid, right, it will tries to the horizontal, then the L shapes, right? Those things we will do, right? And it will call all the vertical areas too, right? So the possibilities are there, and that is why we need the the rotate function here. Okay, so if you see, we will first take the n, then m, and this will store all the result, you can say, that we are getting to, we are getting the return, you can say, as a return, right? So that we have to take, and this is the thing we are doing here. Okay, and finally you will return from the rotate, right? Means this function will rotate the grid in 90 degree wise clockwise, and so we are not doing what, uh, we are writing only for the vertical split. Okay, I hope you understand. If any doubt, let me know in the comment section. So not only you can say the vertical, but we can use for the horizontal also. Okay, we can use the same thing when we are doing for either for the horizontal or in the vertical. So when we use this grid, right, that time we need that rotate thing, right? So when we call this solve, right, so the solve grid tries to find the horizontal L shapes that we have understood, and also it will try to cover the vertical cases. Okay, for this case, the main searcher is the grid, right? We can say the main searcher. So it will try three kind of partitions, you can say, right? The very first is the top rectangles, right, and the bottom left and the bottom right. So when we talk about the what do you call top one, right? So we know that top one will start from where? It should start from 0, right? There will be I will be there, right? And it will go to m minus 1. So this is for the top rectangles, right? This is for the bottom left, and this is for the bottom right. Okay, so you understand this, right? So very first you will go for all the I and j, that is the minimum main thing we have to do, right? We have to operate for on the I and j, because you need to uh, calculate, right? Because this is your m and this is your n, so I will start from 0, it will go to the till the n, like that. Okay, and you will calculate the top one, top rectangle, bottom left, and the top bottom right. Okay, so these three will calculate and you will get the res. Okay, right? We have to find the minimum. Very first you multiplied it, then you will try to find the uh, what you call as small as possible, right? The congested one, you can say, that is using the mean, right? That as we have understood, this is the problem requirement. Okay, we have to find the as minimum as possible, right? Minimum area we have to find, not the maximum, and that is why this is your maximum one and we are finding the minimum one. I hope you understand this, right? Then let's suppose when we talk about the L shape, right? So this is the you can say we are talking about the L shape. Okay, so when we go for the L shape partitions, right, we'll try to use this one. So we have to split this into the grid, right? Let's suppose there will be top rectangle and two bottom will be there, right, in the left one. So for the two left one, we'll try to do again, we will try to split it. Okay, so we'll try to split the very first grid we have, right? So I was talking about, we have the L shape, right? Like this. Okay, so this is your top one, or you can say you can take like this also. Either any of these case, this is your top, and these are two bottom one, right? Like that we are saying. So this is what we have here. Okay, so when we go for the partitions, L shape partitions, right? This is what we have, correct? Okay, where once we'll do the partitions, right, we have to split the grid into two things, right? One big rectangle will be there, and another two bottom rectangle will be there. So we have to split the bottom rectangles into left and right. Okay, so this is your second variations we have to write here, where this will be your uh, uh, top left column. Okay, this will be your top right, and this will be your bottom. Can we say that? So for this is plus one, so we can write here like this also. For remember, you give your comment in your code, just you write the double slash and you keep memorizing that. Okay, once and two time you will do, you will understand it. Similarly, we will do for the horizontal one, right? Where let's suppose if this is your thing, right? uh, the case of, let's suppose this is your top, right? Then this will be your, become what, the middle one, right? And this time this will become your bottom one. So you can think like this, right? You have to split it into the two top left, right? You can put the top on two, right, on the two side, and one will be the bottom one. Understand, right? So this can make you again a L shape, right? So we can treat this as a what, as a top. We can treat this as a middle, and this will treat as a bottom. Can we say that? We can say that, right? Then we should think about what, sorry, I was talking about this one. We have already talked about, okay, yeah. Okay, so this is what we have done, right? And this is for the what do you call, the horizontal steps. The horizontal steps, we have to use these things, right? Top, middle, and the bottom. And this checks the dividing the grid into three horizontal bands, right? Since you are also rotating the grid, right, this will cover all the three vertical steps cases. Okay, and you will get the thing. Very first, you know the you have to rotate the grid, right? This is your rotated grid, right? Try to pass both cases. Thus you have to solve for the grid and the rotated grid, where we will cover all the three cases: vertical strips, horizontal strip, and the L's. Okay, L partitions. Okay, all the cases for the grid and the rotated grid, and you will find the minimum, right? Because we are doing the mean. Which one will give you the mean that you have to return? I hope you understand. But if you have still doubt, let me know in the comment section. Okay, so what we have the final answer? We have to find the best coming from the partition in the original orientation and the partition in the rotated orientation. So you can say which handle the vertical cuts in this case, right? So that's all I have. Let me know in the comment section that you understood or not. If you have any doubt, please ping me in the comment section. You guys, thank you for watching this video. The next one. Also, if you want classes, right, I'm going to start again one more classes. I got some inquiries, so 3 classes is already running, and I'm going to start another class. Let me know in the comment section. You can find the contact number as well as the available courses. You can choose according to your preparation journey. Okay, if you want 3 month, 4 month, 5 month, right, whatever you want, let me know in the comments. We'll plan accordingly, according to your choice, according to your target companies, whether you're targeting for the product based companies or you're targeting for the FAANG. So that's all. Thank you guys. Thank you for watching this video.